Recording in progress.
Okay, so I think let us begin with today's session. So, hello everyone. Uh, I am Mohammad Shoaib. I'm an architect and also holding BIM specialist position in. Uh, so I'm working as BIM specialist in Capricorn, and along with me I have Bishwajit and others. He is also an architect. Tanveer may also join in between. He is a mechanical engineer. So our panel will present you. So we all together prepared some demos, some examples of facade, which are climate responsive. So we together will present here, and so your questions will be welcomed. You can put up that in question and answer box, that is Q&A box, and after the session we'll take up all your questions. So without further ado, let me share my screen. So I think my screen is visible. Yeah, I think, yeah, it is visible. Just a minute. So today's topic of webinar, so it's a part of our webinar series. We take up technical webinars uh, weekly or sometimes quarterly. And in this case, it is one of the part of those series, technical webinars. The topic is climate responsive building facade, and especially by using Revit and Dynamo. So you all got this invite, I believe. So the agenda for this webinar is that we'll take 5 minutes briefly for introducing our company and also the intent of webinar. Although I've already mentioned the intent, now company I'll introduce. Then we'll discuss about passive design measures for climate responsive facade. So as an architect, it is our responsibility. So I'm an architect. So as an architect, this is our responsibility to create a facade which is climate responsive, which is aesthetically looking good, and also functionally it responds to the microclimate. So we'll discuss about those measures. Traditionally and the modern ones. We'll also discuss about how complex facades can be easily built in Dynamo, in Revit. So Revit is as a BIM modeling tool, you already know that, but I'll showcase some part where quickly where it can be used to build complex facades. Then we'll take up that facade, whichever we build in Revit, into Revit solar analysis tool. And then after getting the analysis, we'll simulate as per the solar input via using Dynamo. And then we'll open for question answer. So these are short sessions, 15 to 10 minutes each session, and we'll quickly take you through all the options. So today's intention is to give you the overview of all these options rather than getting into the detail. So about my company, so we are Capricorn Technologies. Capricorn is India's leading AEC technology solution provider. AEC stands for Architecture, Engineering and Construction Industry. We are here since 1987. So we have a legacy of 30 plus years, and we are currently serving 20,000 plus Indian clients, and we do have international presence as well. Currently, we have more than 10 locations in India where our office resides. Our head offices are in Delhi, Mumbai, Bangalore, and Hyderabad. I'm from Delhi division. 250 plus tech-savvy teams are available with us. So we are part of BIM consulting team here. So we do have other technical teams also. You might have seen our webinars on infrastructure side, on manufacturing side. So we do have different, team members. So in our team, we have 40 plus BIM experts, like I mentioned, and all of us are OEM certified professionals. Uh, like I mentioned, we have a global presence now by the name Arkan's company. So we are a part of bigger company called Arkan's. Its presence is globally in UK. I mean, in Europe, in US, we have Indian presence, and similarly, we have Australian partners also. So at each part of the globe, we are present by different names, and we are a part of a larger group called Arkan's company. So now coming to the webinar part. Uh, so passive design measures. So for climate response. So obviously, active design measures, you might have already seen that once a building is completely ready, then you put up air conditioning elements in your building, and then air conditioning load gets too high that your building's operation cost gets very high, and in that case it is not sustainable for a longer time. So either you revise the design of the building later on, renovate the building, or maybe you will not be able, it is abandoned many times or demolished. So if we start with implementing passive design measures at the design stage, obviously we'll get more thermal comfort in the building, and the operation cost will get lower as well. And that is the focus for, especially from facades point of view today. So climate responsive facade can be achieved by vernacular means also. So we have some historical examples from vernacular of elements implemented in facade, such as traditionally, like all of you, I think, might have already either traveled to Rajasthan or maybe seen those pictures. Rajasthan has, I mentioned Rajasthan because it has arid and semi-arid climate. It is mostly hot and dry. So implementation of architecture elements such as jalis, jharokas, that is, screens and kind of bay windows, they play a vital role in reducing the overall heat it gets. So this is one of the examples, jharoka, right? So the kind of a bay window, but it actually, does not allow sun to directly get into the interior space. It kinds of cuts down the because it is not no more this the flat facade. It changes the geometry of the facade, and in a way, implementing bay window in the form of jharoka will obviously reduce the heat gained by the facade. Another example from one of the Havelis in Jaisalmer. So it has jalis, as you may notice, small perforations in the facade, and also the jharoka, that is a kind of bay window. By implementing small perforations in the facade and changing the length of the perforations, you get a Bernoulli's effect. So those who are uh, maybe physics enthusiasts, they might have already remember Bernoulli's effect, where when a liquid, or in this case air, passes through a small uh, a vein, or in this case through jali, its velocity increases, and thus it cools down the temperature. Another example you might have already heard about, Hawa Mahal. The name Hawa Mahal is kept as its function is to collect the air. Now the area is quite populated here in Jaipur, so that is why it doesn't collect that much of air. Traditionally, it used to collect, but the purpose of Hawa Mahal, the orientation of this facade is as such that it collects ample amount of air for the interior space. Then another example from Jaisalmer Havelis. So these are vernacular examples. Another vernacular example from another part of India is implementation of wind catcher. What is a wind catcher? So similarly in Hyderabad, like I mentioned, it has semi-arid climates. It has the rainfall available, but it has lesser rainfall. So it has less rainfall. That is why it gets more humid sometimes when rain falls there. It gets very dry when there is no rain in this area. So they implemented wind catchers as the means of again reducing the overall heat of the facade it receives. So this is one of the picture from 1800. Today, I think you don't see, because now the modernization has been modern techniques has changed the facade, the overall skyline of this Hyderabad, but this is the older skyline. So I collected this picture from one of the historical archives. 1800s, during 1800s, this is one of the picture of the Hyderabad, where you may notice there are certain buildings where several buildings actually where these structures are created. Although it's black and white image, but I think you may notice it. Like farther, you may notice there. So these are chimney-like structure, but these are not chimneys. They're collecting wind in this case. And if I may present the section here, this is how its section looks. So what it does, it is a slanted roof on the top and a chimney-like structure. Whenever wind flows, it catches that wind and it passes through a duct, or in this case through a shaft in the interiors of these spaces, thus cooling down the temperature. Also part of facade structure in Hyderabad. So in our vernacular example, we might find many passive design measures which can be implemented in today's environment also. Otherwise, in modern days, since technology is getting, with the rise of technology, we have different options available. So in modern examples, we have this multi-layered facade system now. So this basically implements multiple layers in a facade. While placing multiple layers, it creates, air gaps in between, and those air gaps can be controlled to control the heat passing through the facade layers. So for example, if you implement glass on the outer edge of the facade and sunlight is falling on that glass, through radiation, this heat is passing through the facade. There's another layer of facade, so it is creating a cavity in between. So it is not directly passing through, passing inside the interior of these spaces. Another facade is there to trap that heat. And while this shape of, I'm considering two layers only, for example. So if a multi-layered facade is these are two vertical layers, its top and bottom can also be closed. Once it is closed, the heat which is collected through radiation is trapped and can be transferred automatically inside through radiation in winter season. If you open this top and bottom panel, then the facade, the air will flow through this air gap, and whatever heat is trapped here through the exterior layer of the facade will get dissipated automatically for the cold environment. So it's a good system for climate like India. So in most of the regions of India, we have climate which can get up to 50 degrees also in summers, and in minus temperatures in, sorry, I'm getting some notifications. Yeah, so in a negative temperature in some of the areas of India. So here multi-layered facade can be helpful. Another example is dynamic facade panels. That and it is globally done in many examples. So I'll take one example of it. So with the rise of technology, like I mentioned, the modern facade implements openable, collapsible panels. Basically, you place a window which is openable. Now you place a shading device which is openable, and this can be not only controlled manually but via motors also. Uh, and if you automate this process, the process of opening and closing the panels can be automated by making the panels climate responsive. That is, if the temperature rises outside and the panel gets heated, the panel shall automatically close. So that is how it can be implemented. So some of the examples are vertical shading device, horizontal shading device, obviously multiple shading device. But these devices can also be manually operated, or can be motorized, or can be automated by running some program behind it, right? So those are basically dynamic facade panels. So I'm just a minute sharing my screen again so that you can hear the sound in the video as well. Okay. And I'm running this video. You hear this video. This is about multi-layered facade, like I was mentioning, and then we'll move. It's a small video.
Double skin facade system is a new technology for our energy-efficient building design. It is normally a pair of glass separated by an air corridor. The main layer of glass is usually insulated. The air space between the layer of glass acts as insulation against extreme temperature, wind, and sound. The width of cavity can range from 10 cm to a meter. How it works. In cold climate, when the sunlight hit the outer facade layer, inside the cavity space start to heated, and the heat transfer inside the room, which helps to reducing the demand for indoor heating system. In a hot climate, the upper and lower vent have to kept open. When the cavity space start to heat, it is pushed out, bringing a cool breeze inside the cavity space. So this how double skinned roof system work.
Yeah, sorry. So I think you saw this video where we try to explain that multi-layered facade can, like I already explained it in my own words, this is also explained in this video. So multi-layered facade system, and if we implement, dynamic panels with it, it will give us many possibilities, right? So here's one example, another example where we have movable panels, right? And these movable panels are placed as vertical and horizontal shading devices. As you may see in this section, here it is a sliding panel, and it can be slided inwards or can be rotated also, right? And similarly, this panel can be splitted to fold itself. So these are different possibilities. Either you can get a sliding panel or rotating panel or maybe folding panel. And this, so we are using the same shading device. We may implement multi-layered system in this case. And these panels, if we make rotatable, collapsible, foldable, then it becomes dynamic facade. So some more examples from different examples. This is Kaifer Technic showroom in Austria, where you may notice all these panels are motorized. These are around operated around 50 motors by 50 motors. These are 200 panels on the facade. You may Google about it, Kaifer Technic showroom. It is in Australia. Uh, all of these panels are openable. Basically, these are openable windows, but and it's a multi-layered facade. As you may notice, there is another layer of glass at the backside of it, and these panels can be opened and closed as per the requirement of the people inhabiting this place. Although these are not automated. Another example where this system has been automated is Al Bahar Towers. So these are two towers in Abu Dhabi. You may also Google about it. These towers have this facade system. So this is the front view of that facade when you pass through this road beside it. It's a multi-layered facade. As you may notice in this case, there's a layer of glass facade. Then this hexagon exoskeleton is placed to hold the facade. I think you can see the exoskeleton. Then, these panels which are openable. These are umbrella-shaped panels. These are star-shaped panels. This is the shape of the panel, right? So we created this paper model and took a picture to show the shape of it. So this is how it closes and opens up. It's a triangular panel. And this is one of the videos where the close-up shows how this panel opens and closes, right? So this panel opens and closes as per, and it is automated as per the heat it gains. So if the temperature rises to a certain degree, it is programmed in such a way that it automatically opens up to provide the shading for the interior space, right? So now, if you need to implement such measures in your design, although it's partially uh, 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 direct measures, it's not like passive measures, it is kind of active measures also. So it's partially active, not completely passive. But again, if you want to implement such, you can create multi-layered facade. I think some of you already know Revit or similar BIM tools. You can create multiple layers easily. But to implement such options where you have dynamic panel in place, and also to simulate this process to convey the idea to the client, in that case, BIM tools will be helpful to you. So today our motive is to show that kind of workflow, right? So now we are showing the role of BIM tools in designing such complex facades, right? So let us switch to the live demo. Just allow me a minute. I'll switch my screen. So I think my Revit screen is visible. Yeah. So I've just shared my Revit screen. I've already created this facade, as you can see, some file by the name Façade, but I'll not directly jump to that. I'll just show you the basic workflow of it. You usually start with your discipline template, or you may start with any template. You may have your organization template, depends. I'm directly jumping to the massing tools. So for getting the conceptual mass out of it. So I'm just creating a facade layer, facade surface, or mass, whatever you call it. We do have, in Revit options such as point-based geometry, where we can, maybe I'll just take, just to start with, 10 meters of gap, right? I'll take up 20 meters in this direction. So we have 3 points. I'm getting to 3D view to show you things properly. I'll switch off levels layer, not needed. I'll just simply convert that into reference line. And this reference line, since controlled by points, can achieve curvature as well. So because it's a 3-point geometry, if you get to have, if you get more points, you'll get more, obviously, control over this geometry. So what I'm doing, I'm placing more points. So I would like to trace the same location of the points. So I'm placing points over points, and I'm getting the confirmation message in the, and I'm just raising these points by certain height. Let's say, suppose the height of this is 15 meters. I can just simply connect them together, right? So I can just simply connect these 2 lines together and create a solid form out of it, right? Turning it into shaded, you may notice. So since there is no material, that is why you cannot see the material here, but it has the curvature option available. You can curve it. So I'm taking the example of, in this case, suppose it's a multi-layered facade, right? So rather than creating one layer, you can just simply do it multiple times, copying this. To give it a gap, you can just implement gap and can also introduce parameters accordingly if needed. I'm giving, let's say, 1 meters gap or something, right? So these are a 3-layered facade, right? So you can select all these points and can move it, I believe, right? Once moved, all of these will be curved. So multi-layered curved facade can be created. So like we have that Al Bahar Tower example or Kaifer Technique showroom example. If it is curvature, then you can give curvature. Otherwise, you can keep it straight. Now, before implementing any type of panel, how do you decide that? To decide that, you should know the location. So this is the general mass, basic mass. So whatever is the shape, you just figured out the shape. So obviously, you can get into the detail of massing and you can get further options available. But in my case, if I need to get the proper, suppose this is the mass which is implemented, I would like to get the proper solar input it is getting. So what I can do, I can maybe, just for the sake of implementing some material, I can just simply add any material for now, right? So obviously you can also add material properties in Revit, such as, for example, if it's I'm planning to have a metal facade, like metal panels. So I'll just take some metal here, right? And metals, physical and thermal strengths can also be fed here. Thermal properties such as thermal conductivity, which is given here watt per meter Kelvin. If you change the units, you can also change it to BTU or some other unit system if you want. So this is basically thermal conductivity U value of the element. And similarly, R value of the element can also be given. So I'm assuming to have a metal panel at the first layer. Second layer, I would like to have glass panel, for example, right? So that metal panel would be openable, for example, right? So that is what I'm planning. The second layer, I'm putting some glass here. And again, for glass, we have different options for glass. We have some colored glass options also if someone wants to get into that part of it. So in this case, we have different color glasses. Anyways, I'm going with the simple glass, clear glass. And we do have thermal and physical properties to modify here. So according to your local, materials availability and local vendors, you can just simply change these properties, right? So that way you can set up U value, R value, SHGC value, and all of those values which are important for running energy analysis. So I'm assuming I've set 2 layers here, right? Obviously, I've not figured out the geometry yet, because for that I would require some data from solar input. So to run the solar analysis, Tanveer has helped me already. So I'm trying to run the analysis here. He's from mechanical side. So I'll try and do it. If I get stuck, so I would request Mr. Tanveer to help me. Anyways, So in this case, I'll go for solar analysis, which is a plugin available. So you can also download that plugin. It is available on Autodesk website, and you can go for solar analysis part. You can run the entire analysis from here, right? So we do also run some workshops on energy analysis time to time. So you just keep in touch. You may notice that we have already taken some energy analysis sessions. Those are also available on our YouTube channel. So we do have YouTube channel by the name Capricorn, and in future we'll also take a few more energy analysis sessions. So you may also get connected. Anyways, so it's a part of that already. So I'm trying to run it. So I'm going for solar analysis. It asks me to select the surfaces. I'm going to select the surfaces. In this case, I've selected this surface. I'll just finish it. It has given me the area which is selected. In this case, I've just randomly created some figure. So that is why, although I was random, but Revit is not random. In this case, it has given me the area. This is 329 square meter. And accordingly, if you obviously set up your facades, you get the actual area of it. I'll just update this, and after updating it, it runs the solar analysis, right? So this is the amount of sun it is getting, right? 1018 kilowatt hour per meter square, right? And this is the highest value, and this is the lowest value. But the problem is the location is Boston. And like I said, I'm not no expert. Tanveer has, I just learned it from the experts. So I forgot to set up the location in this case. So let me set up the location and change the inputs then. So this is how dynamically it works, right? So I'll just undo the process. And let us set up the location first. So to set up the location, obviously Revit has all those settings available. So you can manage your settings and go to the setup of location. Obviously your internet connection should be there. By default, Revit sets up the location to Boston because it's an American tool. I'll set it up, for example, if I'm setting it up for New Delhi, I can just jump to the New Delhi location. As you may notice, it's a mini map here. You can also, pinpoint your location. And after setting up the location, it sets up the weather data. So all of these are weather stations. So if I, for example, hold my cursor to these weather stations, if I hold my cursor there, it is showing the latitude, longitude, and the weather station options about it, right? I'll click OK. So weather is now updated. So our sun is being set for New Delhi in this case, right? Similarly, we can also further change sun settings for time and date. So I can just go for still time. I can also, check up the time and date. It is picking the current date and time. Tanveer has also, mentioned that we can also switch on sun path in this case, right? So if I, sorry, not solar study, sun path can be switched on by going to its properties. So in this case, sun path can be switched on, and you can also, like I said, choose time and date. It is choosing the current time and date, and live sun input can be shown. And if you can also interact with this object, right? It's interactable. So if I try and interact manually, you can change the time over the air, and you can also change the time over the day. So during the day, I'm going for a different time, and as you may notice, it is updating live all those shadows. So shadows are accurate in this case, and it's set for New Delhi location, right? So this facade is getting some sunlight. What amount of sunlight it is getting, that can be run by using solar analysis tool. So I'm going for solar analysis tool, and I'll just simply make selection again. Okay, sun is now very dominant on my screen. Let me switch off sun path for a while. Yeah, now I'll go for solar analysis. I'll select this. I think I've mistakenly changed the time. Just a minute. So let us do it properly. I'm going for single day, still time. The current time I will take, because this is it is around 3:30 now. So I think we get quite amount of sun on this facade during this time. Right, I'll go for selecting the model. I'll select this layer. You can select multiple layers also if needed. I'm only running it for one layer to save time. I'm selecting this layer. It automatically gets the material properties also, right? And then I'll just simply update it. Okay. And then I'll simply update it. So it takes quite some settings. And as you may notice in this case, this is the output we got. All the shadows are quite long. But anyways, now the location is New Delhi. Date and time of the sun is given, right? And in this case, I'm getting more solar radiation from the right side. And on the left side, I'm getting lesser solar radiation. And accordingly, we can decide implement panels accordingly. This solar study I ran for the instantaneous time, but if I change my solar settings accordingly, we can also run it for the multiple days. In multiple days, you can choose from 1 month to another month, or for the entire day, entire year, and you can set up a time also, from sunrise to sunset, or maybe from some other time to some other time in a specific time. So you can also identify the peak hours when your building is to be used. For example, it's an office building, it is to be used from 9 to 6, or maybe it's a residential building, then it is to be used at the evening more than the day, during the daytime. So it depends. If it's a school building, it might be used for half a day. So accordingly, you can maybe set up the dates and time for, because peak months are, for example, in India, we do have heating effect more from April to let's say up to August, or maybe July, August. So we can just set up to August, right? So from April to August, I've set it, and from sunrise to sunset. And if I make these changes accordingly, these results will update. Right. So this is how it is showing the cumulative analysis. And in this case, it requires more shading on the right side of it, because it is getting sun from the western side, and lesser shading on the left side. This is how we can decide. So depending on the location, depending on the solar input, depending on or building curvature or shape, if it had not been curved, agar ye curve nahi hota, so obviously it would receive more sunlight, right? So I hope you got the basics of it. Once it is done, then you can just simply get to the geometry of the panel, right? So I'm just closing it. Okay, so just to save time, like I mentioned, I've already created some facade. Let me open up its original file. Just allow me a minute. Yep, it is opening. So in this case, I've already opened Sun input also. So in this case, you may notice this is a multi-layered facade, and it's an inspiration, as you may notice, from Al Bahar Towers. So if we closely look again at Al Bahar Towers, so I'll share my other screen. So if I search for Al Bahar Towers, and if I check its facade closely, so these are the towers, and it has these panels. Half of them are open, half of them are closed because of the sunlight it is getting, and it is automated. So it's a fascinating example, and there are similar examples also. So Bishwajit has ran a video at the beginning of the session, so that video showed some similar examples. So in this case, this facade, if we look closely, is a multi-layered facade, right? Like we mentioned, if I open this image shows there are three layers. So one layer is of this glass panel, although this image is quite blurry, and another level is this exoskeleton, which is holding the entire structure, and this one is the panel which is openable. So it's a fascinating example in that case, right? So maybe we can check this here as well. So okay, if I open this image only, you may notice this is an openable panel. It is during the construction, and this white strip is basically an exoskeleton. It turns towards this side, so it is in hexagonal shape, and there is this a layer of glass panel, and after that it has the interior space. So there are three layers in total, right? So like in this example, in this photograph, you can see it better, I believe. Okay, this is a very small photograph. I think in this example, you may see it better. It is also a very small photograph. Anyways, just a minute. It is from Arc Daily. Architects do visit this website a lot. So in this case, you may notice one glass layer, then another layer of this exoskeleton, hexagon, and another layer of this panel. So to save time, I've already, created this assembly in Revit. And in this case, it's a three-layered panel, as you may notice, right? So first layer is of this glass panel. I'll isolate it, as you may notice, right? Let me switch off sun path for a while. Right. So it's the first layer, which is directly interactable by the people. It is an openable window, right? How did I create it? I created the mask first, and then I created the single panel and repeated to the entire facade. So this is the single panel assembly. right? So it's a very simple mechanism. So those who already know adaptive family can do it well. Those who do not know adaptive family, they can learn from us. We do run, training programs also at Cape Record. I think most of you already know. Our training programs are by the name. There are 3 training programs which we are currently running from our division. One BIM for design, another one BIM for construction, and another one for BIM for MEP. So obviously, as you may get it from its name, BIM for design is for architects and interior designers. BIM for MEP is for mechanical and electrical engineers, and BIM for uh, construction is for civil engineers and construction professionals. Anyways, so another layer of facade, as I mentioned, is this exoskeleton. So we created this exoskeleton. Again, this is created with the help of massing and adaptive family. If I select one of the panels of it, it's a hexagonal shape panel, which is obviously created in adaptive family and loaded here. Similarly, another layer, which is the crucial one in this case, is this layer. So if I, for example, isolate this one, in this case, you may notice this is the layer where we have this panel geometry. If I edit this, it's quite interesting. And in this case, this panel geometry has been created by using, again, adaptive family. And it's parametric, it's openable. If I, for example, select this portion and pull it up, you may notice the shape is getting changed, right? It is open. Now, if I try and close it, so it gets closed. So if I drag it, it is getting closed. And this behavior of this umbrella shape structure, we controlled by a parameter. And the parameter's name in this case is closing percentage or opening percentage. It depends on the type of perception you are having. जैसे आप perceive कर रहे हैं accordingly. So for example, if I open it by, let's say, 65%, so it closes by 65%. If I closes it to 90%, it closes completely. If I close it only 15%, it automatically changes. So this parameter works in this case. Now, I hope you got the idea. Similarly, we can also do that here. So I'm just briefly, mentioning what we did here. So I'm selecting this panel, and I can control individual panels also, such as this one. Suppose I need to close it 90%, it is completely almost flat. And if I open it to 15%, it is kind of open. And that we can do with all the panels, selecting all the panels. So I use shortcut to select all. 65% opened, right? All of these. 15% open. So it takes a while sometimes because there are so many panels, right? So the geometry is changing, as you may notice, right? And if I simply close it to 90%, for example, this will completely cover the facade. So mechanism is done by using adaptive family and parameters of Revit. So those who already know Revit can, explore this part, adaptive family, and this parameters option, right? So just allow me a minute. So now what we did, sorry, let me unhide it. Yeah, it is all hidden. So in this case, we can also control these panels via using Dynamo. So now we can implement a little bit of programming. So we do have 2 options available. Like in this case, if I open sun path, I can control my sun location, right? But it is not affecting this geometry. So for a software, in a software, we do have data for sun. It can implement sun data. We do have data for this geometry because we created that in as a geometry. So since we have both the options available, we do need to connect them together. So there's a disconnect between sun settings and the panel parameters. To connect them together, we may use a little bit of programming. So obviously, programming is not everybody's cup of tea. So that is why Autodesk, in this case, with Revit, has implemented Dynamo. And Dynamo is a visual programming tool, right? So those who already know Dynamo can, I think, easily get it. Those who do not know Dynamo, intend to learn it, they can again connect with us, or maybe they can, check about it in our other webinars also. We do take one webinar is dedicated for computational design. Anyways, I'm starting with new script, for example, and I'm getting the parametric value of that panel. So what is the name of the panel? So it's a loadable family, as you may notice, right? This panel, sorry. this panel. The name of the panel is Al Bahar panel, right? In this case, the name of the family is Al Bahar panel, and this parameter is closing percentage, right? Parameter's name is closing percentage, by which I was controlling it. So rather than controlling manually, I could have controlled it via using Dynamo. So there are some nodes. So I'll make an automatic selection. I want to select all elements of this family type. So I'll just go for all elements. Sorry, spelling is not correct. All elements. So we get all elements of class, category, level. There are multiple. I want to select a particular family. So that's why all elements of this family type. Now I'm going to select that family by going for family type. So all types of families will be shown in this list. It grabs all the families. So I do have this by the name Al Bahar panel. And since it is starting from, these are alphabetically arranged, so we get it at the top. Now I'll connect it here. So there are 238 panels at this time. How do I know? I can count it, but in this case, it is showing the list of 238 panels. This is the figure it is showing, right? So this is how automatic selection can be done, right? Once it is selected automatically, I can get their parametric value, get parameter value. So we have a node dedicated for that, get parameter value by name. I can connect the elements here and can connect the parameter name. So what is the parameter name? I've already mentioned that, closing percentage, right? So I've selected that panel to show you. This is the name of the parameter. The parameter type is family parameter. So I'll just select this parameter name, giving it this node called string. String means text in this case. So textual input we need to give. So what is the name? Closing percentage. Sorry. Closing percentage. So I'm just connecting it here. And now closing percentage is shown in this case. Sorry. I think I mispronounced the spelling. Sorry, I have a mistake in these spellings actually. Yeah, so percentage. So it is, yeah, so every panel is 90-degree opened. Yeah, 90% opened. Yes. So it is taking the value there, 90%. Now, rather than getting the parameter value, I can set the parameter value also. I can control it via Dynamo. So how do I do that? I'll just go for set parameter. So I think this is your introduction to Dynamo also, those who are very new to Dynamo. So rather than getting the parameter value, I want to set the parameter value. So here we have the element, we have the parameter name. All I need is to set the value. So I can set the value in the form of number. So in this case, we do have number slider. So I'll go for number slider. This slider is quite helpful in that case. I can set it up to 90% so that my geometry won't collapse. Right, 100 is basically flattening the entire panel, which is not possible where it's a metal panel. And least I would like to open it up to 15%. So it is in percentage basically, right? So, and I'll just change it to 1. So all of that can be done. So I'll just simply select the value. So I'll set it up to 50%, for example, to start with. I'll connect it here and it is taking place. Something is going on. And it is updating because there are 200 panels, so it will take a while. So let us wait for a while. And if I now check in my background, panels are updated, right? So let me collapse the library so that you can see both the screens, right? Let me change number of panels so that we get lesser panels to process and lesser time to be processed. So for that, I have already created parameter to control the size of the panel. So rather, so I have this panel size option. It is around 4 meters in actual. So I've given the actual value, but just for the sake of, getting lesser panels so that processing time can be reduced, I just want to show the option. In this case, I've got lesser panels. I've just raised the size of the panel. Now, if I change this slider, for example, so it updates the panel. So okay, let me change it to 15%. Right? So it is updating automatically, right? Similarly, if I change it to 90%, it automatically closes, right? So this opening and closing of this element, like I randomly click here, 34%. So it is 34% open, right? I'll randomly click here. It is around 73%. So basically, Dynamo can control this geometry well. Similarly, in Dynamo, we also get sun data. So if I search for sun data, I'll search for sun settings. So we do get the sun direction in Dynamo, and we also get the current sun settings. So that is, in this case, if I check altitude and azimuth angle of the sun, it automatically takes up, and it also gives you the start date, end date, and current date in this case. So it is currently setting the current date time, that is today's time and today's, okay, I've changed the date, I believe, right? So I've changed the time and date in this case, so that is why date and time is updated. But whatever time and date we change here, for example, if this is 12:45 now, as you may notice, you can also change it like this, or you can just drag it. If I change it to the evening time, this is 15:15, that is 3:15, so it is also updated in this case, 2:45 basically. Ek minute, just a minute, manual, run this script. Is it 2:45? Let me check the sun settings. Anyway, there's a half an hour gap, but no issues. But the idea is, yes, it collects the date and time also. Sometimes, it updates in a while. So we do have both the options. We have the option to collect information from the geometry of the panel, the facade. We do have the option to get the sun settings, right? So after collecting both the information, we can connect them together. How do I connect them? There is an entire process going on. You may again, you are welcome to connect with us for detail of this video, detail of this, sorry, script. So in this case, I've already created the script. Let me directly open that script. Just a minute. Yeah. So let me isolate the panel also. So before doing it, let me undo few changes. So obviously I would need more panels, right? So I'm undoing it. Let me expand the width of it. So I'll just simply change the width of it. I'm changing the facade width and facade height. We do have the parameters available. And I'm also changing the expanding it in a way, right? So just allow me a minute. I'm trying to change it. It is changing. And I'm isolating the layer. So now the layer has expanded, and I'm isolating the panel, right? Yeah. So it is done, right? So in this case, what I did, I changed the width of it. I changed the height of it. So I reduced it so that we get lesser panels and more, expansion, so that we can, see the effects more clearly. And I isolated the layer. Those layers I just made hidden. Here, so you have seen this process. Now I'll just again go back to Dynamo, right? So I'll just go back to Dynamo. The Dynamo is again opening. I closed that Dynamo earlier. Okay, Dynamo is open. I've already created that script, so I'm just directly opening that script, right? Okay, so I closed it earlier. So in this case, like I mentioned, we collected the sun settings, we collected the panel settings, right? And in the scripts, I've done some vector work. So obviously, vector is basically, in physics, you already know, it is the direction of the element. So in this case, we have collected the direction of sun in both x-axis and y-axis. And similarly, we collected the direction of element also, right? So direction of element we created in z-axis. So this is how it is done. So I do not want to bore you with the with this programming information. So if you have the vectors in knowledge, you can figure it out by yourself also. Otherwise, if you want to take our help, you can also connect us in for detailed session. So what I did, basically, I connected the sun vector, that is the direction of sun, and also the vector for panels, that is the panel vector. So basically getting the direction of this panel. So for example, if I, just to show you, if I freeze this node for a while, and if I run this script, right, you may notice in my background, each element is showing their direction, right? So ये जो line आ रही है, this line is this vertical line that is the normal vector of every element. And this, this line, which is slanted, is basically vector from sun. So what we are doing, we are taking a panel, collecting its normal vector. So those who are aware about physics, they can easily get it. Otherwise, you can just revise your physics. So the plane we took of the panel, and then panel's plane is showing the vector. So you can see that geometry here. And another vector we compared for getting the sun direction. So Dynamo can get the vector for sun also, right? Dynamo can get the vector for the direction for the sun. So that sun direction is also getting towards the panel. And whatever is the angle difference, we got that angle difference here, right? So I think you have seen that. So we compared the angle here, vector angle, and these are the different angles which we are getting, a list of angles, right? So, and after getting these angles, what I did, I converted that angle to a formula, and then I fed it to set parameter value by name. So I've already shown this part where we are setting the value of this closing percentage by using this option. So rather than putting our value by your own, like I was doing by the slider, I'm automating it by comparing the vectors between sun and the panel. So anyways, I'm unfreezing it. And if I run the script, let us see the position of sun. I've kept it at 1 p.m. So it is in front of the panel, in front of the facade. And if I run it, for example, I'll run the script again. You may notice it is making changes. Right, so let us wait. Yeah, something happened. Yeah, so in this case, you may notice panels which are directly facing the sun. That is why I expanded the facade so that you can see the changes easily. Otherwise, with chote facade pe, it doesn't see well. Anyways, in this case, panels which are directly facing the sun are closed. Panels which are partially facing the sun are partially opened, and panels which are not facing the sun are completely almost opened, right? So maybe I can select all of these again and can change their opening percentage. Let's say 15%. So that I can reset the data and can show you again. So all of these are open. But once I run the script again, you may notice it will automatically change as per the, where's the Dynamo script? Yeah. I'll run the script again, and you may notice look, as per the location of sun, it automatically changes the closing percentage of the panels, right? Okay. So it is changing, as you may notice, right? Again, it is resetted. Now we can do it live as well. So let's see. I hope my software doesn't crash, but I'll run it automatically. If we run the script automatically, we have the option to run the script manually, automatically, and periodically. Periodically is controlled via script itself. Okay, after a certain period of time, script will automatically run. Automatically will always run the script, and manually will run the script as per our command. So I was running it manually earlier as a precautionary step. I'm running it automatically. Let's see if it will work properly. So by running it automatically, at every time it is processing the data. So if I make changes in the sun live, for example, if I take a morning sun, let's say around 10:45, that is around 11 a.m., it automatically changes the panels. So it is taking place because there are so many panels, it takes time. And it depends on your RAM also. So in this case, as you may notice, the panels which are facing the sun are directly closed. Panels which are farther from sun are almost open, are completely open. And in between, these are partially open, partially closed. On this principle, that facade works. Now I'm checking it afternoon, right? That is 3:15 p.m. It'll update. So if you want to convey certain ideas via BIM tools, obviously these kind of projects are to be done in BIM. Again, you may notice here, this side of the panels are closed, this sides are open, right? I'll set it up 1 o'clock. So if you need to convey the idea to the client, and if you want to get the obviously budget, there are budget constraints also. So these kind of things, if you simulate this via using Dynamo, obviously you have the idea in your mind, you know the passive design measures, but to implement through, but to show it through software, it is another thing. So you show the sun data by running the solar analysis, and then after running the solar analysis, you take the decision that this kind of a panel is suitable. I've taken one example from the live project, which is already done. Similarly, you can implement it by your own design. You can design your own panel accordingly. This is a quite complex shape. Obviously, manufacturer needs to be there has to have some manufacturer for it. You need to find the manufacturer, but you can simple shading devices can be designed, and those simple shading devices once designed can be tested against the sun setting. And for testing, you can just simulate it through Dynamo and can show it to your respective holders also. And in that case, you can convey the idea well. So this is how software and technology help you to convey such ideas. So I hope this, so this was all from my side for today. So in this presentation, we three people work together. Bishwarjit, he's also an architect. Tanveer, he is a mechanical engineer. He helped with the technical data. And some of your questions are already answered in chat box by these guys. And I'll be, so we are also recording this session. We are getting, questions regarding recording also. So that recording will be uploaded to our YouTube channel. You can just follow our YouTube channel. We can upload it in 3 or 4 days, I believe. So this was all from today's session. I believe it was a fruitful session for all of you. So, please stay connected with us, and I'll take a leave on this point. We do have another session. Let me announce another session for the next week. That is by 29th of 29th of next Wednesday, 29th of November. We are inviting Aussie BIM guru, Gavin Crump. So some of you might have already heard about him. He is a renowned architect and also a BIM specialist, and he's a BIM enthusiast. He is a programmer also, so he's many things. And he makes videos for Dynamo users, and he has also covered this topic which we covered. So you can go to his channel also, Aussie BIM Guru, because he's from Australia, so that is how it is pronounced, Aussie BIM Guru. The name of the guy is Gavin Crump. So we have invited him. He has collaborated with us, and just a minute, I'm getting some questions in the chat box also. Yeah. So so I'm putting the our channel link in Q&A box for those who have asked. And Amit sir has asked if there is any performance analysis for double skin facade. Yes, we can take up this to in the report format in Excel or in other formats, and can present it today. Someone has asked about daylight analysis plugin. I would like Tanvi to answer this question, because there is daylight analysis also possible. Okay, so he's saying that yes, there is a plugin available for that, and you can also run daylight analysis on that. Yes, that is possible. So there's a plugin called Dynamo, can also help in that case, right? Okay, so let me complete my announcement. There's another question related to Dynamo. So that next session is actually built around this visual programming, computational design, and using Dynamo to automate the processes, how to deliver your project well. So we have invited Gavin Crump, and he'll be connecting with us. So please do connect with us for the next week as well. Okay, thank you so much. Please allow me to leave at this point. I'm closing the session. Bye, everyone. Thank you so much. Thank you so much for attending.